How's it grade 12s? Today we're going on to annuities and we're going to start with future value. And as you've seen from core maths, future value is working out an investment at the end of the time period. Okay, so you don't have the money now, but you're saving up for that money in the future. Okay, and as you guys have seen, the formula for future value is this, with F being the future value, X being the payment per period, I being the interest rate, and N being the number of periods or payments, sorry. A thing that I do want you guys to note with this future value is the formula for F can only be used if there is a final payment at the end of this time period. Okay, very similar to your core maths. All right, so let's go through example 1. Very simple one. So they're saying here, and guys, don't worry about writing this down as I'm saying it. I will be posting these notes on your Teams channel, so you can always follow from there. All right, so the first example is saying, suppose that 1,000 Rand is invested every month, starting 1 month from now for a period of 10 months. Interest is 18% per annum compounded monthly. The future value of the investment after 10 months would be the sum of all payments together with the interest earned. So we need to calculate what is our future value. So I'm just, this is how I normally do it, just FXIN, fill in the information here. So we've got monthly payments of 1,000. Our interest is 18%. And that is compounded monthly, and this thing is going on for 10 months. Okay, now this one I don't have to multiply by 12 because it's already in months. If they had said to us 10 years, then I would have to multiply by 12 to get it into months. You just need to make sure that your I and your N are in the same units. Okay, so I'm just going to work out what this thing is. 18 over 100. Divide that by 12 and we get 3 over 200. Okay, and this is what we want to find out. Right, so our future value formula, F is equal to X, 1 plus I to the N minus 1 all over I. Plug in my values into the formula. To the power of 10 minus 1 all over 3 over 200. Okay, you can punch that in the calculator and you will get a future value of 10,702 Rand and 72 cents. Okay, so a nice simple example there. All right. Now, being AP, obviously these things are going to get a little bit trickier, but not that much. Okay, so if we look at example 2 now. Example 2 is saying, Kevin decides to open a savings account for his son's future education. On opening the account, he immediately deposits 1,000 Rand into the account and continues the payment to make monthly payments at the end of each month thereafter for a period of 8 years. So I'm just going to stop there quick and I'm just going to explain how I've drawn this timeline. So this is going for 8 years and it's monthly. So I go 8 times 12 and I get 96. So we're going up to the 96th term. Okay, we start at T0 and you can see here he starts payments immediately. So 1,000, 1,000, 1,000, 1,000, all the way up to the very end. He's going to be paying 1,000. Okay. And he also makes that final payment right at the end there. Goes on to say that the interest rate remains fixed throughout this whole thing at 24% per annum compounded monthly. Okay. So what I'm going to do is I'm just going to fill in my FXIN. So obviously we don't know what this is. We know what our monthly payments are. It's 1,000. We know what the interest rate is. It's 24%. And now this one here, we know it's going to be 8 times 12. Okay, and this one here, we divide by 12. Right, I'm just going to work out what this one is. So we get 24 over 100 divided by 12, and we get 1 over 50. And then this one here, we get the 8 times 12, which will give us the 96. Okay, now I just want to talk about what this is, okay? And it's going back to almost that example that you guys did in core, where they spoke about the investment in the CAC 40, okay? That example there, where you've got 1,000 euros, etc., etc. This here is saying that we've got 96 payments, okay? But you can actually see that we have 97 payments because we still got this initial payment here. So what this is assuming is saying that you didn't pay on the first one, but you paid thereafter. Yes, you would get 96 payments, but we have this initial payment here. So what I'm going to do with this formula here is I'm going to add 1 to it. And that 1 is this additional initial payment. Okay, so we add 1 here and we get 97. So that is telling us now that we have 97 payments. All right. So the first question, how much money will he have accumulated at the end of the 8th year? So question A, we're going to use our future value formula. So F is equal to X 1 plus I to the power of n minus 1 all over I. Substitute my values in. Sorry, this is 1 over 150. And we get a final answer of 291,339.59. Okay. Now you guys are probably thinking, okay, that's all fine. I understand how many payments you got and all of that. But surely it should be a future value in advance because you're paying immediately. Yes, you can use the future value in advance. But if you do that, then you must still add on this end bit because that end bit does not get insurance. Okay, so I'll do that for you here and I'll show you how we do that. Okay, so we're going to have this F is equal to X 1 plus I to the n minus 1 all over I. Okay, and because it's in advanced, I have to say multiplied by 1 plus I. That will handle that initial payment there, the payment immediately. But what I must do is I must say here plus final payment. For that one over there, that does not get interest. Okay, so if I fill in all my values here, I'll get 1,000. 1 plus 1 over 1 over 50 to the power of, now this is where you've got to be careful, and that's why I wrote it differently over here. Now this one here will only be up to there, okay, because you'll only get interest for this last payment here. So this N here will be 96 now, because this is only incorporating the interest for those amounts. This one does not get interest, and that is why I added it on the end like that, okay? And this formula only works with the interest added onto those payments, and that is why it's 96 minus 1 all over 1 over 50 multiplied by 1 plus 1 over 50 plus our final payment of 1,000. Okay, and if you work that out on the calculator, you will get 291,339 Rand and 59 cents. Okay, so a lot of you will have noticed that I did it this way in the core example, all right? But now this is because this is AP. I think you guys can look at both methods and decide which one you prefer, okay? They will both give you the same answer. Right, let's have a look at example B. Example B is saying, at the end of the 8-year period, he leaves the money in the account for a further year. How much money will he have accumulated? Okay, so what we've got to do now is, because this is, I suppose we could use just our compound formula. Okay, where our compound formula will be this amount. Okay, that will be our principal amount. So let me do it over here. So question B. We've got A is equal to, P is equal to, I is equal to, N is equal to. Okay, so we want to know what our accumulated amount is. Our principal amount will be this, what we worked out here, because he's leaving it in for another year, but he's not adding in, or he's not paying any additional 1,000 Rand. After this, he just leaves the money in the account, and then that gets further interest. Okay, so that's going to be our principal, which is 291,339 Rand and 59 cents. Our interest hasn't changed. It's still 1 over 50. And our N now is, because he's leaving it in for 1 year, we must multiply that by 12 to get it into months, because this is compounded monthly. So we get the total number of payments is 12. Okay, so A is equal to P, 1 plus I to the N, 291,339 Rand and 59 cents, plus 1 over 50 to the power of 12. All right, you can just punch that on the calculator and you will get your accumulated amount to be 369,489 Rand and 5 cents. All right, so that wasn't too bad. All right, moving on to example 3. So example 3 is saying an investor aged 25 wishes to accumulate 10 million Rand by her 50th birthday. She will pay equal monthly payments into an account paying 15% per annum, compounded monthly. Payments start on her 25th birthday and end on her 50th birthday. All right, so she starts paying immediately. There it is there. And how did I get that 300? The 300 is because it's going from her 25th birthday to her 50th birthday. That is 25 years. And it's compounded monthly. And there's our 300. Okay. Right. So what we want to do is we want to find out what her monthly payments should be. Okay. To accumulate this, so this is 10 million. Add an extra 0 there. All right. To accumulate 10 million. So let's have a look. Our future value, we know we want that to be 10 million. Our monthly payments, we don't know. That's what we're going to work out. Our interest rate for this is 15%. So that's 15 over 100. Divide that by 12. And now the number of payments that we're going to do here. Okay, you can see we've got 300 there, but we've got this initial one here. So this would be 25 times the 12, and that would give us the 300. But what I'm going to do is I'm going to add on that initial payment there, plus 1, and we get 301 payments. Okay, so what I'm going to do here, grade 12, is I'm going to do it the first way that I did it with this one over here. Like this. Okay, as you can see, it's just a lot quicker, a lot neater. There's nothing wrong with this one. You can do it that way, and you'll see in the notes that I post, I've done it both ways for you. Okay, but I'm just going to do it the quick, easy way. Okay. So we've got our future value formula, which is f is equal to x 1 plus I to the power of n minus 1 all over I. Okay, let's substitute our values in. So we get 10 million. I need to work out what my interest is. 15 over 100. Divide that by 12. And we get 1 over 80. $301 payments. Okay, so just like normal core, I'm going to work out what this is in the calculator, and then I'm going to say 10 million divided by ounce, and we will get that x is equal to 3,044 Rand and 7 cents. Okay, if you're interested in the other method, you'll see in the notes how I did it, and that's it for future value. Thanks, grade 12s.